Welcome back, folks. We're moving on to something called arithmetic series. And you might be going to yourself, well, hold on just a second. Didn't we cover that in section 9.2? That was arithmetic sequences. We'll be discussing the difference between the two of those right after we do the start thinking. So let's get working on that. What is 1 plus 2 plus 3 plus 4 all the way up to 100? Some of you may remember we talked about Carl Friedrich Gauss, one of the most famous mathematicians, figured out a way to do this where you flip all the numbers, write them back out this way, 98 plus all the way back out to 1. And when you did that, you came up with 101 plus 101. And you found out that you had 101 written 100 times. But of course, we wrote the thing we were looking for twice, so we had to divide it by 2. And that came out to be something like 5,050. All right, so what's an arithmetic series and what's an arithmetic sequence? Well, an arithmetic sequence was what we were dealing with. So an arithmetic sequence is where we're getting numbers and we're adding or subtracting from one number to get to the next. So going from 6, then we go to 9, then 12, 15, and so on. An arithmetic series takes that sequence and it adds all of the numbers together. So an arithmetic series for that sequence would look like 6 plus 9 plus 12 plus 15 plus and so on. And so all a series is it's a sum of the terms of a sequence. So a series is the sum of terms of a sequence. Now we actually have two different types of series. There are finite and there are infinite series. A finite series is a series where we have a known start and end term. But an infinite series is one that just keeps going. We have to put ellipses on it because it keeps going. So this would be an infinite series, right? We're not saying we go 6 plus 9 plus 12 plus 15. We keep going. If this was just 6 plus 9 plus 12, that would be a finite series. Now here's the important thing that we're going to be learning today. This is a super important formula. The sum, and we're going to write that as big S sub n, of a finite arithmetic series where we have a1 plus a2 plus all the way out to a sub n is our sum is equal to n over 2 times a1 plus a sub n. And if we think about this, this makes sense. Let's go back to what Gauss said, right? He said our series is going to be the number, our first number, plus our last number, the total number of times we have, and then we had to divide it by 2. That's all we're saying here. Our sum is going to be the first number plus the last number, multiply it by the total number of terms, and then divide it by 2. So let's go through some practice with this. Let's say we have 2 plus 4 plus 6 all the way up until 100. Well, what's this going to be? Let's write out our formula. Our sum is going to be n over 2 from 2 to 100, from our first term to our last term. And what's n going to be? How many n's do we have? Well, this is the same as going from 1 to 100, but we're taking out all the odds, so we're taking out half of them, meaning that this is going to be 50 terms. So this is going to be, the sum of those 50 terms is going to be 50 over 2 times 2 plus 100. And if you put this in, you'll find that this is 2,550. Now, what would we do if this wasn't an easy number to find, if we couldn't find n so simply? Well, we'd go back to the formulas we had from the last section, or from 2 sections ago. So you might remember the explicit formula for the sequence was a sub n is equal to a plus n minus 1 times d. If we put all of this in, we can solve for n. Right? A sub n, our largest term, is 100. We start off at 2, plus, we don't know what n minus 1 is, but we're going up by 2 each time. So this is the same thing as saying 100 is equal to 2 plus, distribute that in, we get 2n minus 2, or 100 is equal to 2n. So that would have told us n is 50. So if you can't solve, or if you can't figure out the total number that you have, you can solve for it that way. Perfect. Let's do another one of these. Let's say you have 4 plus 9 plus 14 plus 19 all the way up until 99. Now we don't know the number of terms, and we could try counting it out, but it's going to take forever. So let's do this the way that we just saw. We'll call this one a1 and this an. So our formula is a sub n is equal to a plus n minus 1 times d. And now let's put in everything we know. A sub n is going to be 99, is equal to a is going to be 4, plus, we don't know what n is, but how much are we adding each time? We're adding 5. So this is saying 99 is equal to 4 plus 5n minus 5. Or 5n minus 1 is equal to 99. When you solve for that, you'll find that this is the 20th term. So that's the number we're going to use for that summation equation. By the way, this is super important. It's okay if you look back at them. I only remember them because I've gone through this lesson a couple of times. But take a look back when you need to. So our formula is s sub 20 will be equal to n over 2. Actually, let's write this out. S sub n is equal to n over 2 times our first term plus our last term. So n is 20, our first term is 4, and our last term is 99. So this is the same thing as 10 times 103. So our total sum is 1,030. All right, now we have another way of writing these as well, because mathematicians are very lazy, and these show up in a ton of places. So when we're talking about the sum, we write it using this Greek letter sigma, and we put a number on the bottom and a number on the top. Then we write out the formula. So what do each of these mean? This is your explicit formula for the series or the sequence. This is the term you're starting at. So this is your smallest term. And this is the term you're ending at. Now be careful, this doesn't mean that our first number is 1 and our last number is 100. This means we're starting on the first term and we're ending at the 100th term. And so these are what we call limits. The limits are our greatest and least n values. So, looking at this, n would be or 1 would be our lower limit, 100 would be our upper limit. And so this reads, the summation, right, we're summing these from n equals 1, we're starting at n equals 1 to 100 of whatever this is. So let's take a look at how that would work. let's say you're given this, and I will call this summation, the summation form, maybe, sometimes. It's an old habit, it's what it's called. So if you don't remember what I'm talking about, this sigma is our sum. So let's say we're given this. This is saying we're looking at the equation or the series, the sequence, 5n plus 3. We're starting at the first term and we're ending at the 70th. This isn't saying we start with 1 and we end at 70. We're looking at these. By the way you can tell these are arithmetic, this is linear. And if you have a linear summation like this, it's going to be arithmetic. Right, so this is what we have. Now what we're going to say is this is equal to that equation we had before. So this is equal to n over 2 times the first term plus the last term. And now we're going to, this isn't 1 and this isn't 70, we're going to have to substitute these in to figure out what it is. So we know n is, well, it's going to be our big minus our small plus 1. So our number is going to be our big minus our small plus 1. So 70 minus 1 plus 1, we're going to have 70 over 2. And we're going to substitute in 1. We get 5 plus 3, so this is going to be 8 plus 5 times 70 is going to be 350 plus 3. So this thing here is equal to this. Let's go work through this. So this becomes 70 over 2 is 35 times 371. This is equal to 371. And we put that into our calculators, figure out what this sum will be. That is 12,985. 12,985. You might be asking, why do we use this? Where does this show up? Well, you'll be seeing them more in pre-calculus, and they show up a ton in calculus. All right, now let's go the reverse way. Let's say we're given a sequence, we're given a whole bunch of numbers that are added. Let's try to write it in that summation form. So let's say you have 7 plus 11 plus 15 plus, and we'll go all the way to 203 and 207. All right, so what is this going to be? Let's look at what the explicit form is going to be first. So a sub n is going to be 7 plus, what are we adding each time? We're adding 4, so it's going to be n minus 1 times 4. That's our explicit form, and we're going to have to try to solve for n because we're going to need that. So we're going to put in 207 here. Becomes 207 is equal to 7 plus n minus 1 times 4, or 200 is equal to 4n minus 4. Solve for n, you get 204 is equal to 4n, or n is going to be equal to 51. So we can start our summation here. We're going to say this is equal to the summation. We're starting at the first term. We're ending at the 51st term. And what are we going to put here? We want the explicit equation written as simply as possible. As simply as possible means we're going to look at this and simplify it. So that becomes 7 plus 4n minus 4, or 4n plus 3. So our summation is going to be the summation from the first term to the 51st term of 4n plus 3. Does this work out? Let's make sure. Well, we put in 1, we get 7. We put in 2, we get 11. So yeah, this should work out. All right, let's do another summation here. One more example. Let's say we have this sum written here. What is this going to be equal to? Well, our equation for the sum was n over 2 times our first term plus our last term. So this is going to be equal to, how many terms do we have? 40 minus 1 plus 1, so it's 40 over 2. Our first term, when we sub 1 in for this, is going to be 3 minus 8, so it's minus 5. And then our last term is going to be 3 times 40, which is 120, minus 8 will give us plus 112. So this is going to be equal to 20 times, let's see, 112 minus 5 is going to give us 107, and that will become 2,140. So that's what we have for today. We covered the difference between sequences and series. Series are where we add up all the terms. We have that formula, this one right here, which tells us what the value is going to be. And then we also had that weird way of writing them using sigma notation or a summation notation. Just put a Greek sigma there, just put a letter looking like that. You have your smaller term, your larger term, your smallest number, largest number, and your explicit formula. All right, let's get you all to some practice. I want you to sum up using that equation. Let's say you have 1 plus 4 plus 7 all the way up to 31. Figure out what this will be equal to. And then I want you to find how we'd write this using that notation. So go ahead and pause the video, do these 3 problems, and we'll go back and work through them once you come back. Make sure you're doing these. All right, welcome back. Let's get started with this one. So we have all of these, but we don't know the number of terms. Easiest way to find that is going to be to write it out. So let's write out the formula. Get a sub n is equal to a plus n minus 1 times d. A sub n is 31. We start off at 1 and we're adding, we don't know how many times, but we're adding 3 to it each time. So this is 31 is equal to 1 plus 3n minus 3, or 3n minus 2 is equal to 31. Solve for n here, and we're going to get 3n is equal to 33, or n is equal to 11. So now we have n, and we have everything we need to put it into that summation. Right, we said s sub n is equal to n over 2 times our first term plus our last term. So s for 11 is going to be 11 over 2 times 1 plus 31. Let's put that in. We're going to find that this is, we'll leave that as 11 over 2 times 32. Let's cancel those out. So that is going to be 16. So this is 11 times 16, or that is 176 is our answer for that one. All right, moving on to the next one. We have the same sort of thing, but now we have it in that summation form. We use the same equation, but now we have n and everything. So this is going to be equal to n over 2. N is 6 minus 1 plus 1, so it's 6 over 2 times sub 1 in for this. We get 2 minus 1, so 1 plus 6 is going to be 12 minus 1, or 11. So this is going to be equal to 3 times 12, or 36 is our answer for the second one. Then we have this last one. We're trying to find the sigma for it. So we're going to have to start by trying to figure out what our numbers are and what the equation is. We're going to start with that explicit formula for the sequence. So that's a sub n is equal to a plus n minus 1 times d. A sub n is 38. We start off with 5 and we're adding 3 each time. So this becomes 38 is equal to 5 plus 3n minus 3, or 3n plus 2 is equal to 38. Subtract 2. Let me make sure these numbers are correct. 5 plus 8 plus 11 plus... All right, we're good. I am just bad at math. It's okay. That's what we have calculators for. So we're going to subtract 2. This becomes 36 is equal to 3n, or we're going to get that n is equal to 12. So now we're going to write this out. We're going to say that this, where did we start? We started at the first term, went up to the 12th term. And what's the formula we're using? Well, it's this one right here, the most basic form we have. Going to put it in here. So your answer for the last one should look like that. All right, go ahead and get going with the homework.